Hello everyone. Today I'll be discussing the last topic of the module Introduction of Microprocessors, that is memory. Memory unit is an integral part of any microcomputer system. Its primary purpose is to hold, program and data. The main objective of the memory unit design is to enable it to operate at a speed close to that of the processor. Although technology is available to design such a high-speed memory, cost is the major limiting factor. To strike a balance between cost and operating speed, a memory system is usually designed using different materials such as semiconductor, magnetic, and optical materials. A microcomputer memory can be logically divided into 4 groups: processor memory, cache memory, primary or main memory, and secondary memory. So processor memory refers to a set of CPU registers. Processor registers are the first set of storage devices available for the programmers to store any data, but they are generally few in number, up to a few tens or hundreds. As these registers are available within the processor, they are the fastest memory registers. The main disadvantage is the cost involved, which restricts the number of registers and their bytes. The CPU is a semiconductor device and it operates at a very high speed. Therefore, the speed of the memory should also be very high and it must match the speed of the CPU. If the memory is slow, the CPU has to wait for data and instruction. This will reduce the processing speed of the computer. To match the speed of the CPU, a very fast semiconductor memory called cache memory is directly connected to the CPU. It stores currently needed instructions and data of a program being executed. Its access time is about 10 nanoseconds. It uses static RAMs. The next level of memory which is used in a computer system is the main or primary memory. It is also a fast semiconductor memory. It stores programs and data which is being processed by the CPU. Its access time is about 50 nanoseconds. It is cheaper than cache memory and it uses dynamic RAMs. The main memory is connected to the cache memory. The currently needed instructions and data of the program are loaded into the cache memory from the main memory. Semiconductor memory is a static device. It is faster, smaller in size and lighter in weight and consumes less power compared to other types of memory devices. The main memory of the computer system is volatile. Cache memory is also volatile. It holds information, that is the main memory holds information, that is programs, data and results, as long as power supply is on. Therefore, to store programs, data, results and supervisory programs like operating system, a computer must have a permanent type of memory at the third level. The memory which stores information permanently is called secondary or auxiliary memory. Example, magnetic disk, optical disk, etc. Secondary memory refers to the storage medium for huge files such as programs, source codes, compilers, operating systems, etc. These are not accessed directly or very frequently by the microprocessor in a computer system. Stored information in a magnetic tape or magnetic disk is not lost when power is turned off. Therefore, these storage devices are non-volatile memories. So, the classification of semiconductor memory. There are two types of semiconductor memory: RAM, that is random access memory, and ROM, that is read-only memory. So RAM, as I've told you, it is random access memory. It is used as read or write memory of a computer. They are volatile memory, that is, its contents are lost when power supply is switched off or interrupted. There are two types of RAM: static RAM and dynamic RAM. So basically, static RAM, as I've already discussed in the previous lectures also about SRAM and DRAM, and again here I'll be repeating the same, that static RAM stores bits in memory cells composed of flip-flops. Each cell, which can store a single bit, requires 6 transistors. It does not need to be refreshed periodically as flip-flops retains the data. It has faster access time compared to DRAM, therefore used as cache memory mostly. It has low density or less memory per chip due to more circuitry required for a single cell. The power consumption is more as compared to DRAM because of low chip density. It is more costly in terms of cost per bit compared to DRAM due to low chip density. Whereas DRAM, that is dynamic RAM, has memory cells which is composed of capacitors and transistors. Each cell requires a capacitor which stores bit as charge and a transistor. It needs to be refreshed every few milliseconds to retain data because the charge of the capacitor leaks. It has slower access time compared to SRAM as it cannot be read while being refreshed. It has high chip density, that is more memory per chip compared to SRAM due to less circuitry for a single cell. It has less power consumption than SRAM because of simple circuitry. It is less costly than SRAM because of high chip density and therefore used as main memory in PCs. Moving ahead with ROM, that is read-only memory, that is another type of semiconductor memory. A ROM is a non-volatile memory. It stores information permanently. Its contents are not lost when its power supply is switched off. It is not accessible to user. It is used to store initializing programs of a computer, microcodes of a CISC processor, supervisory programs of a microprocessor kit, fixed programs in microcontrollers, etc. Its contents are written at the time of its IC fabrication. It is cost effective for high volume production because of high cost of preparing a mask needed for writing the desired contents into the ROM. It is simple, cheap and dense, and it uses one transistor memory cell. So there are many kinds of ROM. First one that I'll be telling you is mask programmable ROM or mpmcs. They are custom made for the customer. Their contents are programmed by the manufacturer. Since they are mass produced, they are inexpensive. The customer cannot erase or program it afterwards. The next one is programmable ROMs or one-time programmable ROMs. So these are devices that can be programmed by the user in his or her place using special equipment. The main disadvantage of ROMs is that they cannot be erased and reprogrammed. The next type is erasable and programmable ROM, that is EPROMs. It allows the erasure and reprogramming of the content by the user. In an EPROM, programs are entered using electrical impulses and the stored information is erased using ultraviolet rays. The next is, so moving ahead with the EPROM only. So how are we going to erase the contents of EPROM? I'll be discussing it now. So to erase its contents, it is exposed to high intensity short wave ultraviolet light for about 20 minutes. To facilitate exposure of ultraviolet light, the EPROM chips are packed in a package which has transparent window. The ultraviolet light having wavelength of 2537 Armstrong is used for erasing the contents of an EPROM. An equipment with ultraviolet source called EPROM eraser is available for this purpose. The entire contents are erased in this process. Another disadvantage of this technique of erasure is that the EPROM chips has to be taken out of the system board and placed in an EPROM eraser's chamber. EPROMs are cheap and reliable, hence they are widely used. EPROMs are used to store programs, data or any kind of information which are permanent but need updating. So the next type is EEPROM, or we can also name it as, they are electrically erasable PROMs. So they are also called EAROM, that is electrically alterable ROM. They need not be removed from the system board for erasure. EEPROM is byte erasable, so selective erasure of its contents is possible. Its disadvantage is that different voltages are required for erasing, writing and reading the stored information. It requires a pulse of 21 volts for writing or erasing and 5 volts for read operation. It uses complex memory cell structure and therefore it has low density. It has also high cost and lower reliability. It is used in certain applications where byte alterability is needed. So up to this point only I'll be discussing in this lecture. In the next lecture we will discuss about the secondary memory and its classification. So again I'm showing you the slides that I have discussed today, that is what is memory and what are the types of the memory. Then I've discussed about each of the types of the memory, like cache memory, primary memory, secondary memory. So here I have written small points regarding this memory, these types of memory. Next I have told you what are the types of semiconductor memory, since semiconductor memory is widely used for microprocessors or computer system. So I have told you about the two types of the semiconductor memory, RAM and ROM, and I have discussed their classifications in today's class. So what is RAM? I have discussed that also. The two types of RAM, that is SRAM and this DRAM, this much I have discussed. The next I discussed about read-only memory, that is what is read and only memory and what are the types of the read-only memory. I have discussed about mask programmable ROM. Then I have told you about this programmable read-only memory, then erasable programmable read-only memory. So I have given short points with each slide, with each type of ROM for your convenience. So the next that I have discussed is electrically alterable ROM. So up to this point I have discussed. So we will be ending this class here, and I'll tell you about the types of secondary memory in the next class. Thank you.